Majority of it, like I would say, I've looked at it, like 80, 85% of it, factoring, which makes sense because the majority of what we've done lately in math workshops, factoring. So it's mostly factoring with a couple like simplifying radicals. So if you in factoring are still struggle busing, some person is like, yes, I still just can't factor. You need to come see me or do something, pray to something. You need to do something because you already missed it in Algebra 1. You missed it in Math Workshop. And let's face it, we went over it one day this past week as well. So I don't understand. I will try to understand and help you best I can, but I don't understand. Okay, and if you didn't like factoring, then today's is going to be a little overwhelming for you. Okay, let's start on our math workshop. Here's this problem that we don't know what they're doing. There's Alonzo and Ada. They're supposedly solving a problem by completing a square. And we want to know, is either of them correct? And explain our answer. So are either of these people correct? Well, we don't know what they're doing. What's the line where they go different on? They start off the same. What line number do they go different on? The third, I heard you, Karen. You have your point. So on the third line, life changes. It looks different, but specifically, what did they do differently on the third line? Alonzo added 16 on both sides. Ada did not. So who is correct? One of them is correct.
But he wasn't at 16, he should have added 2. Right.
But he did. He added it to both sides. Ada did not.
So I think Alonzo's right.
Alonzo is correct because of this. And you've been in math class for some time now. You know if you divide by 2 on one side, you divide by 2 on the other. We normally aren't adding numbers. That's strange. The fact that they want it to go higher. I thought 20, but if we do it on one side, we have to do it on the other. So Alonzo is correct. And the reasoning is, if you add 16 to one side of an equation, you have to add 16 to the other side. And that's actually what we're going to talk about today. So if you didn't get that one, that's fine. Not a big deal. Number 18 says solve the equation by graphing and then solve algebraically. Well, I'm going to do it in reverse. I'm going to solve algebraically. It's negative 2x plus 2 equals 3x minus 3. But if we add 2x to one side, we have to add 2x to the other. You know that. So 2 equals 5x minus 3. Yes, dear. You add 3 to both sides, you get 5 equals 5x. So x equals 1, and Ellie, you can have an extra point. Okay, so the solution of this equation is x equals 1. Meaning if we were to plug in 1, these pieces would actually be equal to each other. If we plugged in 1, we would get negative 2 plus 2 is 0. 3 minus 3 is also 0, and so these two pieces would be equal. They're only equal when x equals 1. But it also says to solve by graphing, which seems a little strange, but we can still do it. So we're going to graph y equals negative 2x plus 2, and we're going to graph y equals 3x minus 3. If we graph each piece, this piece, and then the other piece, and we see where these two lines cross, where they cross should also be the solution. That's what we did with systems. Where they crossed was the solution. So theoretically, they should cross at 1. Okay, so negative 2x plus 2. We go up to 2, down to that one, down to that one. We connect the dots. So we've graphed this one. And now if we want to graph the other one, it's 3x minus 3. I go down to negative 3. Up 3 over 1. Up 3 over 1. Up 3 over 1. And I graph this line as well. And lo and behold, they actually do cross at 1, 0. So no wonder we got x equals 1. When we graphed it, we also got x equals 1 as where they crossed. It crossed at 1, 0. The x-coordinate in that is 1. So I think that's a weird way to solve things, but it works. Strange. Okay. Speaking of strange things, get out your name packet. So we've been on this kick with quadratic equations, and sadly that kick's not going away. Chapter 4 is quadratic crazy. Because honestly, once you can do all the math with quadratics, you can do all the math with any kind of function. If you fully understand quadratics, we can take that and apply that to about anything. So we've been graphing quadratics, we've been factoring to figure out the solutions, we've been talking about complex numbers to try to help us with this. And there are 2 more strategies we're going to learn on how to solve a quadratic equation. So if you can't factor, you might want to try what we're going to try today, which is completing the square. And then if you struggle bust with completing the square, you can always go to the quadratic formula. Now, truth is, in real life, I get to choose what I'm doing. I'm a creature of habit. I quadratic formula it 90% of the time. If it's not an easy factor that comes straight to my head, I've got that quadratic formula down, I plug it in, so I got an answer, and move on with my life. But that's not how life goes in math class, as you know. So in the next test, we'll have actual specific parts that say, solve this by completing the square. Solve this by the quadratic formula. It's kind of like with systems. So if it said solve by substitution and you solve by elimination, you didn't get your points, did you? The same way, if it says solve by completing the square and you don't complete the square, you're not going to get your points. So we're going to have to accept we've got to complete the square. Okay, when you hear square, what do you think of? Especially when we're talking about quadratics. I do think of an exponent of 2. Yes, that is true. I do think of x like x squared. I do think of square root. But I also think of perfect squares. As long as you didn't say a box, we're good to go. Okay, so I'm going to tell you the basic setup on number 1, and then from then on out, we're going to just repeat and make it an easier process. But I'm going to explain why we complete the square on number 1. Okay, so let's go ahead. Right now, I can't factor it. 11 times, I don't want to go there. So I probably can factor it, but I'm not going to. So what we're going to do first is move over the 11. Forget your 11, go to the other side. So x squared plus 10x equals 11. We wish there was some number we could add on the left, and because this is math class, if we add whatever this number is on the left, we're going to add it on the right. But we're going to put some serious thought into what this number should be. Because what we want is to end up having x plus something squared equals something. And I'll even be more specific. I'm going to end up having x plus 5 squared. So I've got to figure out what that last number would be. That way I could end up having this. Yes, 5, you have a point. Okay, so for those of us who are like, I don't know, it's Wednesday. So let's actually FOIL out x plus 5 times x plus 5. We get x squared plus 5x plus 5x plus 25, which is x squared plus 10x plus 25. So that mystery number we're looking for is 25. So we figured out what the mystery number is. It's 25. If only we added 25 to each side, life would work out pretty on the left. And on the right, it still ends up being a perfect square number. So that doesn't seem that bad. Now we're going to continue to solve in just a moment. But let's be honest. Not all of us can just instantly in our head think through, oh, that needs to be a 25. If we could do that, factoring wouldn't be such a pain to begin with. So that's what we're going to talk about. It always, I'll probably write this at the top of my paper. It always, the last term, if you'll take your middle, which for us was 10, if you'll take your middle and you divide by 2, and then you square it, you'll always get that mystery number. So in our case, we did 10 divided by 2, and then we squared it. So we got 5 squared, which is 25. But let's be honest, that's a lot of work to have to do in our head. It's a good thing we've got this calculator. So seriously, no matter what, the middle term, which is always the term next to the x, we're going to type it in. So in our case, it was a 10. 10 divided by 2. And then square it. And it gives us 25. Now, I get the easy ones like this we could have done in our head. But we're going to get to some that aren't as easy. And it's still going to be the same process. Middle number divided by 2 squared gives us that mystery number. Okay, but notice middle number divided by 2 is 5. And notice that middle number divided by 2 is what I picked to go here. So before you square it, you did middle number divided by 2, and then you square it and it goes there. And it works out the same way every time. So let's go ahead and look at number 3. We'll go ahead and get them set up. So number 3, it's x squared minus 8x. I'm going to move that 65 over. I need to figure out what this mystery number is that's going to help me complete the square. It is going to end up being 16 because middle number divided by 2 squared does end up being 16. But on the next line down, I'm going to have x minus 4. Again, it's always middle number divided by 2 gives you the bottom number. And then when you square it, that's when you get that mystery number we're looking for. Yeah, that one adds up to 81. Thank you. Okay, and we're going to finish solving in just a second. We're going to finish solving in just a second. No, because negative 4 times negative 4 is positive 16. Did you do negative 8 divided by 2 and then square it? Okay, you should get positive 16. Okay. Are there any questions about this setup? Okay, well, we're going to continue to see it through and solve it, but you can go ahead and put an E by 1 and 3, because 1 and 3 are easy. I'm not trying to say that this process is easy. I get it. It's going to be a pain. You can already tell. But compared to the other problems, 1 and 3 are easy. Okay, so we want to get just x by itself. So we're going to take the square root of both sides. Back to number 1. So when I take the square root of the left, I get x plus 5. But on the right, I actually have plus or minus the square root of 36. Back to, remember, quadratics are supposed to have 2 solutions anyway. And we're not really sure. You know, I know you know the square root of 36 is 6. I get that. But we're not really sure if it was a negative 6 or a positive 6. Back to, once you start squaring stuff, everybody's positive. So that's why we do the plus or minus. Okay, so really we have x plus 5 equals plus or minus 6. And so if I wanted to move that 5 over, I could write it as x equals negative 5 plus or minus 6. But let's face it, those are nice, pretty numbers. I can actually calculate that. So I want to do x equals negative 5 plus 6. Well, that's 1. So one of my answers is 1. I also want to do x equals negative 5 minus 6. I did my plus side over here. I did my minus side over here. And I got negative 11. So my 2 solutions are 1 and negative 11. Are there any questions about this? Now, bless Karen's heart, if the problem says completing the square, she's got to solve it by completing the square. However, no one's saying I'm taking the graphing calculator away from her. So why not also graph the function and make sure it actually crosses the x-axis at 1 and negative 11. And you know you're not crazy. Okay, let's go to number 3 and we'll finish him. So on number 3, if we take the square root of both sides, we're going to have x minus 4 equals plus or minus what number? Jax, you said it first. You can have the point. So we actually have x equals 4 plus or minus 9. Tell me one of my 2 answers. Not negative. Thank you, Roberto. You can have the point. Okay, so it's x equals 4 plus 9, which is x equals 13. And it's x equals 4 minus 9, which is x equals negative 5. So it's negative 5 and positive 13. So Roberto is correct. Okay. number 2.
Because it's gonna be a guess. Like when you square 13.
What's wrong in the 13?
You'll get, it's not perfect.
Well, 10 wasn't perfect. 8 wasn't perfect.
You get negative 6.5.
Well, when you divide, it doesn't work out well. So what's wrong with 13? What is not? He's not
Even.
We're looking for even things. He's not even. Yes, number 2, you get an extra point. So we're looking for even ones. If the middle term is even, life seems to work out nicely so far. It worked out nicely on number 1 because 10's an even number. Worked out nicely on number 3 because negative 8's an even number. So looking at, we don't even want to touch with a 10-foot pole 4 or 5 because those leading coefficients aren't 1 and we just don't even want to go there yet. But we can go to number 6. It's got another even, so let's go to 6. And earlier today, I was going to say number 6 is for you to do for homework. And I would be so mean if I said that. Because this one, even though it looks like an easy, we're going to classify it as a medium. That's what the M is for. I'm still going to do x squared plus 8x plus something equals negative 22 plus something. I moved the 22 over. I realized there's going to be something missing. Yes, it does end up being that.
And then you do x plus 4 squared.
You do.
38.
Equals what?
38.
It's negative 22. That's the problem. You really did. You were on it.
Negative 6.
Okay, so Angel's right. Top line worked great. Second line was great until we got to this negative 6. All the others were pretty. It was 36. That was nice. 81 was really nice. We're still going to keep going. We take the square root of both sides. I get x plus 4 equals plus or minus the square root of negative 6. I need to write that better, don't I? How could I write that right-hand side better? Say it again. It's going to be square root of 6i. Yes, Timothy, you can have that extra point. Okay, so I'm going to go ahead and move the 4 over too. So it's plus or minus the square root of 6i. Again, we saw that negative under the radical. Anytime you see a negative under the radical, I is now your BFFFF. Negative under the radical means I needs to happen. Literally, this is the answer I'm looking for. This is the answer any math teacher ever would look for. This is the answer. This is it. Now, if you want to break them apart and write negative 4 plus square root of 6i, and then negative 4 minus square root of 6i, you can, but it's way faster to do the plus or minus. If you have been tuning me out as I've gone over complex numbers and you never watched the complex number video, you probably realize there's an I button on your calculator. Down there in your catalog, there's an I button. Right there. And sometimes it works out nicely when you ask your calculator to do that math for you. But most of the time, not so much. Literally, if Seth types in negative 4 plus or minus square root of 6 and then he presses the I button on his calculator, he's going to get some weird answer. Yeah, he gets negative 4 plus 2.44449. I don't want that. I do not like that. I want negative 4 plus or minus square root of 6i. So if you give me this, you know that means I know that you don't know what you're doing when it comes to imaginary numbers. Just FYI. Okay. Just so you know. We are going to be brave and go to number 2 now. I know number 2 seemed intimidating because number 2 had that 13, but it's still just a medium. It's still the same process.
So we can still put 6.5.
We are going to press frac, not frac. Okay, so still the same setup. X squared minus 13x plus something equals negative 36 plus something. And I'm still going to take the middle, divide by 2, and square it. Every single time, middle divided by 2 squared. it just was nice when the middle was even. When it was like 10 divided by 2 is 5 squared is 25, life worked out good. Now it's 13 divided by 2 and then square it. Okay. So I can still use my calculator. I can say I'm supposed to do negative 13. That's what my middle is, negative 13. Then it says divide by 2. Great. And then I need to change that to a fraction. I don't want it to be negative 6.5. I press math, frac. It's negative 13 over 2. Weirdo. Now I square it, and I get 169 over 4. So while it's a pain that the mystery number I was looking for is 169 over 4, seriously, negative 13 divided by 2, and then square it. Yes, I see the 42.25 or whatever it is you did. I don't want that. I want the fraction. In fact, on our next assessment, I'm pretty sure at the top in bold it says no decimals. If you give me decimals, you're going to have a problem. Well, I would have rather see 169 over 4 versus 42.25. Tell me about 169 over 4. What's special about it? They're both perfect squares. Yes, 2 and 4 get a point. They're both perfect squares. I would rather see 169 and 4 because those are perfect squares and we can work with that versus 42.25. What is that? I don't know. I can't deal with that. Okay, so we figured out the mystery number. It is 169 over 4. Which does seem rather yikesish. So, let me move my other papers. I agree. I know this is x minus 13 over 2 squared. I now have to add negative 36 plus 169 over 4. So either you can get common denominators, is that what you did? You could get common denominators and actually work this out by hand like I did on my original key. And then I was like, wait, it's Wednesday. That's not how they want to do that today. Literally, my calculator knows how to do math. I've already told it I want fractions. I might have to tell it again, but it already knows I want fractions. It remembers that last thing I typed in. It knows what you just last had. So if you press plus and then negative 36, it literally will add negative 36 to your answer of 169 over 4. Lo and behold, 25 over 4. Your calculator did the math for you. You didn't have to find a common denominator. You didn't have to potentially mess it up. Everything's nice. And 25 over 4 is still 2 perfect squares, so it still sounds great. Okay, are there any questions about these 2 lines? I swear this is the hardest part of this one. Okay, well then it's the same old, and I take the square root of both sides. I've got x minus 13 over 2 equals plus or minus, and you're smart, so we're going to jump straight to what? I'm not going to put square root of 25 over 4. I'm going to put 5 over 2. Thank you. You can have the point. I'm going to put 5 over 2 because I know square root of 25 is 5. Square root of 4 is 2, so I'm jumping straight to that. So the last period asked at this point, are we done? Are we done? We don't have x by itself. Why would we be done? Okay, so x equals 13 over 2 plus or minus 5 over 2. Now are we done? No, we can do this. This is not rocket science. They've got denominators of 2. We can add. You can even put it in your calculator. Your calculator knows if you tell it 13 divided by 2 and then plus 5 divided by 2 and then you turn it into fractions. Like it can handle it. Or wait, it was a whole number. It was 9. It's just 9. So your calculator can do this. But I'm sorry, I like some math in my head. At least sometimes it makes me feel like I can do things. So I knew it was 13 over 2 plus 5 over 2. That's 18 over 2, which is just 9. So yes, one of the answers is 9. And then with the subtraction one, I have 13 over 2 minus 5 over 2, which is 8 over 2, which is 4. So I got 4 and 9. But again, my calculator can do all this for me. And God bless the calculator, it can still help you out. You could always still graph it, see where the roots are. If it crosses at 4 and 9, you're not crazy. Speaking of roots, there was a good question I should have asked on number 6, and it didn't come out then. On number 6, our answers were -4 plus or minus the square root of 6i. What does that mean about our graph of our parabola? What does that mean about its roots? They're imaginary, so it has no real roots. So should it cross the x-axis? So when I graph number 6, if it crosses the x-axis, I've done something wrong, because according to my answer, it shouldn't cross, because my answer has eyes in it. Just another 2 cents. Okay, flip to the back. We are trying not to touch the ones with a coefficient larger than 1 today, because they look scary, even though they're really not. So what problems are we going to skip?
8
and 10. Yeah, so 8 and 10 you can skip for now.
Should we skip 11 because of those numbers?
We are not going to skip 11. We're going to be brave. In fact, we're going to be brave, and you have 3 problems. Now, I don't know how y'all always get ahead of first period, but you do. There is also a checkpoint involved. So if you would like to go ahead and do 1 and the 2 on the checkpoint, you could today. You have enough time. I'm going to say, just so you know, so you have to do 7, 9, and 11. I think 7's a medium. I'm going to go ahead and tell you the answers so you can make sure we're on the same page. On 7, the answers are 2 and -3. It's a medium because of that middle term of a 1. It's not an even number. Okay, number 9 is an easy, but it involves complex numbers. My answer is 3 plus or minus 4i. Number 11. Let me tell you about him. I'm going to call him, I refuse to call him a hard. I'm call him a medium plus. He's a little exceptional. The reason he's a medium plus is because he's annoying, like Angel pointed out, because of that 3. It's not an even number. He's also annoying because when you take the square root, you end up having a negative, so you have to use I. So you have 2 options for an answer. If you want to write it as one giant fraction, then you would want to do -3 plus or minus the square root of 15i, all divided by 2. That's one giant fraction answer if you want to do it that way. You don't have to. If you like it to be 2 separate tiny fractions, then it's okay if you have -3 over 2 plus or minus the square root of 15 over 2i. These mean the exact same thing. One involves 2 tiny fractions, one involves 1 giant fraction. Are there any questions about this? Well, you've got time. You could probably get these 3 done, and if you're wanting to be brave, come see me, and I'll go ahead and let you do part of it. I know you can do at least one of them. It's a 3-question checkpoint. You can do most of them.